Right now, look up. Now imagine it's just gone. No eclipse, no explosion, no warning. 1 second the moon is hanging there like it always has. The next second, nothing. A black hole where 4.5 billion years of history used to be. You wouldn't feel it happen. For the first few hours, almost nobody on Earth would even notice. But here's what scientists say happens next. Earth starts to wobble. Not metaphorically, literally. The exact 23.5-degree tilt that gives you seasons, that keeps ice caps frozen and coastlines where they are. That's not natural. That's the moon acting like a gyroscope, holding this planet steady. Pull the gyroscope out, and Earth starts drifting the same way Mars does right now. A planet with no moon of its own, and no stable climate to show for it. And some scientists ask an even darker question. Without the moon, would complex life have ever had a stable enough climate to evolve here at all? So let's actually run the experiment. Hour by hour, year by year, eon by eon. Starting with the ocean that's about to stop behaving the way it has for your entire life. The most immediate physical effect would hit the oceans. Tides are caused primarily by the moon's gravity pulling on Earth's water, creating a bulge on the side facing the moon and, a little less intuitively, a second bulge on the opposite side, caused by the moon's pull being weaker there than at Earth's center. As Earth rotates through these two bulges, we get our familiar 2 high tides and 2 low tides each day. The sun also contributes to tides, but it's far weaker than the moon's effect, even though the sun is vastly more massive. Because tidal force depends heavily on distance, and the moon is so much closer. Remove the moon, and the sun becomes the only source of tides left. Ocean tides wouldn't disappear completely, but they'd shrink dramatically, down to roughly a third of their current height. The dramatic tidal swings that shape coastlines, flush estuaries, and drive entire marine ecosystems would flatten out almost overnight. This matters more than it sounds like. Tidal zones, the areas that flood and drain twice a day, are some of the most biologically productive environments on Earth. Countless species, from horseshoe crabs to migratory birds to entire coral reef systems, depend on tidal rhythms to feed, breed, and survive. A sudden permanent shrinking of tides would be an ecological shockwave moving through every coastline on the planet simultaneously. Here's something most people don't know. The moon is slowly stealing Earth's rotational energy, and in doing so, it's been steadily lengthening our days for billions of years. Through a process called tidal braking, the moon's gravity creates a slight drag on Earth's rotation. Right after the moon-forming impact, roughly 4.5 billion years ago, a day on Earth is estimated to have been only about 5 hours long. Today, thanks to the moon's gradual pull, that's grown to 24 hours. And it's still slowing down by about 1.7 milliseconds per century. Interestingly, that slowdown wasn't perfectly smooth. Research published in 2023 found that for roughly a billion years, from about 2 billion to 600 million years ago, Earth's day length actually got stuck at a steady 19.5 hours because a countering solar tide in the atmosphere temporarily cancelled out the moon's braking effect. Without that billion-year pause, today's day would likely be over 60 hours long. If the moon vanished, that braking effect would stop instantly. In the extremely long run, Earth's day length would essentially freeze in place rather than continuing to slow down. But the more immediate, chaotic problem isn't the day length. It's what else the moon has been doing this whole time, keeping Earth from wobbling. This is the part of the story that turns inconvenient into civilization-altering. Earth spins on an axis tilted at about 23.5 degrees relative to its orbit around the sun. That tilt is the entire reason we have seasons. It's why the northern and southern hemispheres take turns leaning toward the sun throughout the year. Crucially, that 23.5-degree tilt has stayed remarkably stable for hundreds of millions of years. And the leading explanation for that stability is the moon. The moon's gravity acts like a gyroscopic stabilizer, keeping Earth's tilt locked in a narrow, predictable range, wobbling only slightly over long cycles. Without the moon's steadying gravitational influence, a landmark 1993 study modeled Earth's tilt as becoming chaotic, potentially drifting anywhere from nearly 0 degrees to as much as 85 degrees over millions of years. Compare that to Mars, which has no large moon to stabilize it. Mars's actual axial tilt has swung between roughly 0 and 60 degrees over its history, and remains a live example of what an unstabilized planet's tilt can do. It's worth noting this isn't entirely settled science. A follow-up study in 2011 ran more detailed simulations and found that a moonless Earth's tilt might not swing quite as wildly or as fast as the original 1993 estimate suggested, in part because Jupiter's gravity also plays a stabilizing role on the whole solar system. So, the honest scientific answer is, without the Moon, Earth's tilt almost certainly becomes less stable and more chaotic than it is today. But exactly how extreme that chaos gets is still debated among researchers. If Earth's tilt started swinging like that, seasons as we understand them would stop making sense. A tilt near zero would mean almost no seasons at all. Every location on Earth locked into a near-permanent climate. A tilt near 85 degrees would mean entire hemispheres pointed almost directly at or away from the sun for extended periods, producing seasons so extreme that regions could experience months of continuous sunlight, followed by months of near-total darkness, with corresponding temperature swings severe enough to disrupt agriculture, ecosystems and weather patterns across the entire planet. This wouldn't happen overnight. It plays out over hundreds of thousands to millions of years, but it's the single most serious long-term consequence of losing the Moon. Not romance, not tides, but the slow unraveling of the climate stability that allowed complex life and eventually civilization to develop in the first place. Zoom back into something more immediate: darkness. Without the Moon, nighttime would become dramatically darker. Moonlight is reflected sunlight, and while it's faint compared to daylight, it's still enough to see by, navigate by, and for an enormous number of species, regulate behavior by. Countless nocturnal animals rely on moonlight for hunting, navigation, and mating cycles. Sea turtle hatchlings famously use the reflection of moonlight on the ocean to find their way from the beach to the water. Artificial light already disrupts this today, and losing the moon's light entirely would remove that navigational cue everywhere, all at once. Coral spawning events in many reef systems are synchronized to lunar cycles. Countless predator-prey relationships are tuned to the amount of moonlight available on a given night. Pull the Moon out of the equation and you're not just dimming the sky. You're deleting a variable that ecosystems have been calibrated around for hundreds of millions of years. This raises a deeper question that goes beyond what if the Moon disappeared. Some scientists ask whether complex life could have emerged on Earth at all without the Moon's stabilizing effect from the very beginning. The idea is this: a young Earth without a large, stabilizing Moon might have experienced more extreme and chaotic climate swings than it actually did, similar to what's estimated for Mars. Those swings could have made it harder for complex, multicellular life to gain a foothold over hundreds of millions of years. But as mentioned earlier, this is genuinely contested. The 2011 follow-up research suggests a moonless Earth's climate swings might have been survivable rather than sterilizing, meaning the Moon may have made evolution easier and more stable, without necessarily being a strict requirement for complex life to exist at all. Either way, it reframes the Moon from nice to have to, at minimum, a major contributor to the calm conditions that let us get here. So, would we survive? Short answer, yes. Tomorrow morning would still come. The lights would still turn on. Nobody drops dead because the Moon vanished. But surviving and unaffected are two very different things. The shrinking tides and the darker nights are the part you'd notice first, and the part that matters least. The part that actually decides whether this planet stays livable is the one you'd never notice at all. Earth's axial tilt, quietly starting to come loose. That drift plays out over hundreds of thousands of years, not headlines, but it's the one that eventually unravels the climate stability that agriculture, civilization, and everything we've built depend on. So the honest version of the answer is, we'd survive the first day easily, survive the first century almost as easily, and then spend the next several 100,000 years finding out just how much we owed to a rock we never once had to think about. Thank you for watching this video, and for more like this, subscribe to Industrial Origin.